Lie back. Let your shoulders loosen. Breathe out, slow and even. Tonight, we will drift gently, not across oceans, but through quiet skies far beyond our own sun. Each stop will be a soft fact, a little lantern of wonder. No hurry, no puzzles to solve, only images to hold as you let sleep come closer. If you enjoy these quiet voyages, a soft like or a subscribe helps others find this channel, only if you'd like. There is a world so close to its star that day and night have melted into one continuous furnace. Its name is Celt 9b, and if you imagine standing near its surface, you would feel heat like a steady oven, a glow so fierce that molecules in the air struggle to hang together. This is an ultra-hot gas giant, a planet not of rock you could stand on, but of thick, boiling gas. The important thing to know is simple. Its closeness to its star makes its atmosphere leak away slowly into space, a gentle, endless sigh of material drifting outward. Picture that sigh as a thin, shimmering veil pulling away into the dark. It is not violent here in our story. It is a long, soft unraveling, measured in ages. Perhaps somewhere within that flow, atoms recombine and dance into new forms, a slow chemistry of loss that goes on without hurry. Further on, other peculiar weather waits. Elsewhere, on a planet we study as HD 189733b, the rain does not fall as drops of water, but as tiny beads of glass, if you can believe it. Winds there do not stroll, they race sideways, sweeping anything that forms into a glittering drift. Imagine a sky that throws shards of molten glass like snow, swept so quickly they streak across the horizon. The scientific anchor is quiet and clear. The atmosphere is hot enough and contains minerals that can condense into tiny molten droplets, and strong winds push them in long lacquered sheets. We call that image glass rain. It is a strange, sharp beauty, and it remains in our minds simply a picture of nature being creative in its extremes. Imagine standing far away from such a world, watching it spin, knowing the spectacle happens and is not meant for us to endure. Meanwhile, a softer motion is coming. Closer to a heavy, rocky core is a planet named 55 Cancri E. It has been described in a hushed kind of speculation. Under extreme pressure and heat, carbon-rich interiors might crystallize into forms we dream of as gemstones. Some scientists have suggested diamond-rich layers beneath molten crust. The fact we hold gently is this: the composition of the planet, with lots of carbon, could lead to unusual materials under pressure. Speculation remains speculation, framed as a thought rather than a fact. Picture deep layered geology humming with a slow heat that makes mineral dreams possible. It is a poetic idea, not a promise. Let the image be a smooth, heavy stone warmed in your palm. Now drift a little farther and think about how planets move. Most of the worlds we picture sweep the same way their star spins, but some do not. Imagine a planet called WASP 17b traveling the opposite direction around its star, a silent traveler moving backward through the sky. That reversal is called a retrograde orbit. It simply means the planet's path goes the other way compared to its star's rotation. Picture the sunrise there arriving from an unexpected quarter, a slow, polite surprise of light. The explanation is calm. Interactions during the planet's youth, close dances with other planets or passing stars, can flip or tilt orbits. They do not scream, they rearrange over long, patient stretches of time. Nearby, a different rhythm plays. Kepler 78b is another kind of overtime world. It orbits so close that its year lasts only a handful of Earth days. The sense is of a planet caught in a short, relentless circuit around its star. To imagine it, think of a small stone kinetic toy turning near a candle. Its surface bakes and cools quickly, then bakes again. This is ultra-short period orbiting, and the scientific anchor helps us understand proximity. Being that close means tidal forces and heat make the world an intense, stitched rhythm of burn and brief relief. There is no rush in the telling, only a steady pulse you can match to your breathing. In, out, in, out. Now, somewhere under twin suns, light plays another gentle trick. Some planets circle not one star, but two, drifting through sky lit by twin dawns and twin dusks. These are circumbinary planets. Picture a sky where shadows come in pairs, where two low suns spread a slow wash of color. The sensation is intimate, two soft lights that take turns warming different parts of the world. The scientific anchor is elegant and simple. The planet orbits both stars, moving in a stable pattern that lets day and night fold in ways we do not have at home. Sometimes the light overlaps, giving a lingering, prolonged twilight. Elsewhere, one star hides, and the world slips into a darker hush. Imagine walking in the space between two soft suns, the air tasting of long, slow seasons. Meanwhile, the skies themselves carry weather stranger than any we have on Earth. On some gas giants, clouds form from minerals rather than water. Think of clouds the color of sapphires or curtains of metallic compounds that catch starlight like distant lanterns. We use words like silicate and iron-rich condensates to describe them, but the feeling is tactile, a sky that shimmers with mineral dust, a hush of tiny solid particles floating in a warm, heavy breeze. Winds there can be sonic in terms of the local atmosphere, not a violent roar, but a steady, high-speed flow that shapes clouds into long streaks. If you imagine such a sky at night, it might glow faintly at the edges, auroras tracing lines along a planet's magnetic field. Those auroras are the same kind of gentle light show we see near Earth's poles, only sometimes broader, deeper, more slowly moving. Let your eyes follow one ribbon of color, drifting until it blurs at the edge of sleep.
On some worlds, metals rain down. On others, clouds are made of vaporized rock that condenses into tiny grains, falling like soft metallic snow. The scientific note to carry is quiet. Different temperatures and compositions create different chemistry in the sky, and by reading that chemistry, we learn what the planet is made of, from its cloud decks to its deep hidden layers. We listen to light to do this, a concept we'll come back to later, but for now, keep the image of a purple glassed horizon, of a slow metallic snow that melts into nothing before it reaches any imagined ground. Such weather is alien, but not hostile. It is simply another way a planet can look when conditions shift. Further on, imagine a planet wrapped in an endless twilight. Some exoplanets are tidally locked, meaning one face always points to their star while the other faces perpetual night. TRAPPIST-1 is a system where several small, rocky planets sit locked in this way, their days and nights arranged like a permanent portrait. On a tidally locked world, there is a ridge of temperate calm along the terminator, the narrow ring between day and night, where light is never too fierce and dark is never absolute. The scientific point is soft. Being tidally locked means the same hemisphere stays warmed, while the other stays cool, and between them is a band that could, in some cases, be gentle enough for milder climates. Imagine walking along that thin line, the air neither scalding nor frozen, a slow, unchanging twilight that could soothe the senses. This is possibility, not certainty. It is an idea that invites you to picture comfort in an unlikely place. Now, imagine oceans so deep that pressure turns ordinary water into strange crystalline ices of forms rarely seen on Earth. These are ocean worlds, planets or moons with blankets of liquid deeper than any sea we know. Beneath their waves, at pressure and heat unknown to our surface, water can become a different texture altogether. The scientific anchor is steady. Tidal heating, radioactive decay, or residual formation heat can keep these interiors warm, allowing liquid layers to persist under a shell of ice. Picture for a moment a horizon of glassy blue that hides a warm, slow ocean, currents moving like slow thoughts, not storms. If life were ever to find a niche in such a place, it would be tucked in warmth beneath ice, where chemistry is patient and time is abundant. Again, we speak of possibility, not proof, a soft invitation to imagine a hidden warmth. Some worlds show their restlessness through icy eruptions called cryovolcanoes. Instead of molten rock, these vents push out water, ammonia, or nitrogen, sometimes mixed with salts and organic compounds, a cold plume that freezes into tentative structures as it meets the low-pressure sky. Picture a dim mountain cresting, releasing a pale plume that glitters and drifts down like a slow, cold steam. The image is quiet and clean.
Scientifically,
Cryovolcanism suggests internal energy, a hidden engine under ice, a place where liquid pockets might persist. These are places of slow renewal, where chemistry can be renewed by internal motions, not by sunlight. Hold the idea like a small ember, glowing softly under a dark crust. Meanwhile, independent wanderers drift in the deep. Rogue planets have been nudged free of their stars and slide through interstellar space alone, carrying their internal heat like a lantern in a vast, cold room. Imagine one of these as a quiet marble, faintly warm, its atmosphere thick and insulating, possibly keeping a surface, or its deep interior, at a slow, persistent warmth. The scientific anchor tells us that while they are removed from stellar light, they can still retain heat from formation or radioactive decay. They are not instantly frozen, but rather move through deep time with a kind of melancholy grace. In the dark between the stars, such a planet is a silent, solitary traveler, content in its long motion. Some planets cling to the dead light of remnants. Around white dwarfs or neutron stars, planets can orbit in strangely beautiful ways, wrapped in the faded glow of a star's last breath. These places tell stories of endurance and of transformation, worlds surviving the evolution of their sun or being reshaped from debris into new forms. Rings of debris can gather and coalesce into planetary fragments, painting a ringed sky of slow, delicate particles. Picture a night where the moon is a broad band of shimmering dust, slowly turning, a quiet halo of history. Each ring is a memory of formation, a soft archive of collisions and reassembly, told in quiet, glittering language. We have been speaking of shapes and motions, of textures in skies and under surf. Now let us pause and listen to how we know these things. The methods are simple and lovely if you think of them as acts of attention. One of the ways we learn is by watching stars blink. When a planet crosses in front of its star from our viewpoint, the star dims a tiny bit. We call that a transit. Imagine the star as a distant lamp and the planet as a careful finger passing between you and the light. The depth and pattern of that dimming tell us the planet's size and orbital rhythm. It is as gentle as watching a moth pass the moon. Another method is the star's small wobble. A planet tugs on its star, and that tug, seen in the star's light, reveals the presence of a companion. We call this radial velocity. The star shifts subtly toward and away from us as the planet walks its path. Imagine a slow, imperceptible nod, an almost hidden reply to the planet's presence. By measuring that nod, we learn about the planet's mass, its tendency to be heavy or light, and thereby its character. Both methods, transit and radial velocity, are like listening to light and movement as if they were breathing. We also read starlight like a fingerprint.
When starlight passes through a planet's atmosphere, certain wavelengths are absorbed or scattered. That pattern, a spectrum, tells us about the atmosphere's composition: hydrogen, helium, water vapor, or other molecules. Think of it as a gentle color code, a whisper of what the sky is made of. Large telescopes and sensitive instruments tease out these whispers, turning them into facts we can ponder in the quiet. Some of our most sensitive eyes are missions with names that feel gently human. Kepler taught us to watch the night patiently, cataloging transits like the steady counting of waves. Tess scans nearby skies, finding bright, close targets for deeper study. And larger observatories, the James Webb Space Telescope and the Nancy Grace Roman Telescope, are our most sensitive, patient gaze, able to read the faintest whispers of starlight. Imagine them as lantern bearers on a slow, deliberate expedition. They do not rush. They collect light as if saving it, stacking it, and listening until a word or pattern emerges. With all these soft tools, we start to find candidates for gentler, temperate worlds. Names like Kepler 442b and TOI 700d come to us as possibilities, carefully labeled, each one sitting in a zone where liquid water could, by the slightest chance, be stable at the surface, only under the right conditions. We always hold the word candidate close. It is a polite label that means worth studying further. Picture these planets as small, patient lights on a distant shore, possibilities that invite curiosity without insisting on conclusions. When we look at their spectra for biosignatures, delicate chemical hints like oxygen or methane in certain balances. We treat them as clues, not announcements. The search is gentle and tentative, like listening for a distant footstep in a vast hall. Beyond mere catalogs, there is a slow crescendo in capability. The idea of taking a portrait of a planet once seemed fanciful. Now instruments are pushing toward direct imaging, making a tiny, dim picture of a world next to the bright glare of its star. Imagine the first blurred portrait of a distant world sharpening over years into a map of color and clouds, and maybe hints of weather. The promise is patient. We will likely see coarse features first, broad strokes of brightness and darkness that tell us where clouds gather, where heat pools, how seasons might move. Each refinement is small, but together they build a more intimate sense of place. It is comforting to think that even as our instruments improve, the universe keeps its own slow pace. Planets turn and orbit in long, steady rhythms, indifferent to our schedules. They are patient teachers. They allow us to learn in fits and starts, to form gentle theories and then revise them, to imagine and then test. That humility in our methods is part of the comfort. We do not claim more than we know.
We speculate with care. We speak softly about possible oceans and temperate bands, and we leave open spaces where mystery can rest. And in those spaces, the imagination does its quiet work. Picture now a planet whose night side is littered with auroral curtains that bloom and fade like slow flowers of light. Picture a terminator ridge where dew gathers in a perennial dusk, where air moves in long, slow circulations that never feel hurried. Picture mineral clouds catching a two-sun sunset and keeping its color like a memory of warmth. These images are not facts to memorize. They are soft petals you can hold as you drift, gentle tokens of the variety of planetary stories. Some of these images are born from a simple, reassuring truth. Cosmic processes are patient. Stars and planets live on timescales we can barely sense. A planet's orbit can take millions of years to settle. A ring system can persist for eons. That slow motion can be calming if you let it be. When you picture a ring of debris turning lazily around a distant world, imagine each particle moving not with haste, but with a long, predictable rhythm. The universe keeps its own time, and that time is ample. Now, imagine a quiet shoreline on an ocean world we have only just begun to suspect. The waves would not crash like ours, perhaps. They might be slow, deep undulations, pressing gently under a pale sky. If the ocean is overlaid by a thick atmosphere, the surface could be muffled, sound dampened, the swell moving like a very long breath. Think of the smellless air carrying no urgency, only the soft notes of chemical mixing at the water's edge. In our studying, we would look for hints of salts or organics in the atmosphere, just gentle signs that chemistry is taking place. We must remember to treat these signs as possibilities, not proofs, and hold our wonder like a light we do not demand to be answered. There are other, still quieter scenarios. Consider a planet where the seasons are so long that a single summer can last centuries, and a single winter can last centuries more. The idea of slow seasons can itself be a lullaby. Imagine trees, if there were trees, moving their leaves in a wind that changes so slowly you could watch one leaf shift over many lifetimes. The science here is simple. Long orbital periods and axial tilts can stretch seasons to durations far beyond human experience. Allow that stretching to calm you, a reminder of the patience threaded through cosmic rhythms. As we move gently from imagined shorelines back toward the mechanics of discovery, a tiny thought arrives. These places exist whether or not we ever visit them. Their weather writes itself in silicates and ice. Their long migrations and rearrangements happen quietly. For us, the pleasure is in learning their stories in slow chapters, one transit here, one spectrum there, until a picture forms. Further out in our voyage tonight, a world drifts that has survived the death blow of its star.
Around a white dwarf, planets may circle a husk of a once brighter sun, their days lit by a cooler, fading light. The image is not bleak, rather it is a landscape of soft, silver afternoons. Particles of debris can form rings, or a planet may show scars of past upheaval, but the overall sensation is of continuity. Matter rearranges, settles, and becomes new. The scientific note is precise and calm. The existence of such planets tells us about the resilience and rearrangement that follows stellar revolution. Imagine a sky with a narrow, pale sun and a ring at the horizon, both telling a story of change and endurance. Meanwhile, in the quiet between discovery and imagination, we sometimes meet contradictions that are themselves soothing. A planet might show water vapor in its spectrum, yet be too hot at the surface for oceans as we know them. Such contrasts remind us to hold no single picture too tightly. Instead, we learn to appreciate complexity. A sky may harbor water in high clouds, a glowing interior may hide a cooler surface, and atmospheres can be layered like soft membranes, each with its own chemistry and mood. These layers are like pages in a well-loved book, each turned slowly, each revealing something gentle and new. It is almost time to let the mind rest on a single image, a final, soothing picture that carries into deeper sleep. Picture an artist's palette of distant skies, glass rains, metallic snow, sapphire clouds, twin sunsets, and a terminator band of perpetual twilight. Think of telescopes as the hands that gather enough color from those skies to begin telling us what each hue might mean. Hold the feeling that knowledge is patient and kind. It arrives on a steady tide, not a sudden wave. As you follow the thought of that palette, notice how your breathing can match the cadence. A slow intake as one world appears, a longer out-breath as you let the details soften and fade. Let the rhythm repeat. The next part of our journey will listen more closely to the whispers in starlight, how we read spectra like fingerprints, how direct images are made, how portraits of weather might one day appear. For now, keep the images gentle. Allow the palette to blur into soft color, and let your eyes close if they wish. Meanwhile, drifting somewhere beyond the warmth of stars, a solitary planet keeps its own small heat. Imagine it not as a harsh exile, but as an elegant loner, its internal glow keeping pockets of potential alive. The idea is comforting. Isolation does not equal emptiness. It can be a quiet persistence. Let that persistence be your companion as the scene fades and quiet takes over. Breathe in, breathe out. The universe is patient. The planets keep their slow courses, indifferent to our timing, ready to be rediscovered whenever we wake again. For now, let each fact be a lullaby. Let the strange, the beautiful, and the possible fold into a soft, spacious dream.
Let that soft image settle, the planet keeping its quiet heat as it moves through velvet dark, and let your mind glide with it, without urgency. Further on, the universe keeps arranging matter into new stories. In one corner of that slow workshop, planets are born and reshaped in ways both violent and gentle, like a potter pressing and polishing clay for ages. Imagine you are near a ringed world, where the rings are not merely thin lines, but broad, luminous bands. Each little particle within those rings moves with a patient rhythm, colliding and settling, catching the star's light and scattering it into a thin, steady glow. The sight is almost musical, a soft, repeating shimmer that circles the planet like a lullaby. From a scientific angle, rings form from debris left over after collisions or from material that never quite gathered into a moon. They can be fragile, slowly losing material to space, or they can persist for eons, held in place by gravity and subtle resonances with moons. It's possible in some systems that rings hide tiny moons within them, barely more than dust and rock, forming slowly over time. Picture those hidden moons as slow seeds of new shapes, turning invisible hands into possible souvenirs of long histories. The image is quiet and patient, a slow necklace of motion. Elsewhere, imagine a planet skirting the edge of destruction and creation, a world that once was part of a larger body, now rebuilt from the ashes of collisions. Debris disks around young stars look like clouds of glittering sand, and within that shimmer, planets can accrete and grow or be chipped away by close encounters. The scientific note is calm. Collisions in early planetary systems can scatter material,
sending it into orbits that later coalesce. Speculatively, some planets we see may be the survivors of such cataclysms, their surfaces marked by ancient scars. Consider that thought as a slow healing of old wounds, the cosmos reshaping itself without hurry. There are other quiet denizens, brown dwarfs that sit between the smallest stars and the largest planets, glowing faintly from their own residual heat. Picture one as a warm ember, neither bright enough to be a sun nor cool enough to be a planet in the strictest sense. They can have atmospheres with clouds, storms, and chemistry that resembles giant planets. The scientific anchor is simple. Brown dwarfs form like stars but lack the mass to sustain long-term hydrogen fusion. They cool over time and can host planetary companions or complex atmospheres. Imagine standing at a respectful distance, feeling the vague comfort of a dim companion that radiates warmth like a distant campfire. Meanwhile, some planets circle the last light of a dead star. Around white dwarfs, the remaining glow is thin and silvery, like a memory of day. Visualize a world under a pale sun that never grows fierce again, a hush of permanent twilight.
The fact to hold softly is this. When a star evolves and sheds its outer layers, surrounding planets can survive in altered states, or new material can congeal into fresh bodies. Speculation here is gentle. Such systems might hold planets reshaped by extreme history. They might wear scars of their star's final breaths. Picture the landscape as weathered and soft, a place of second chances where light is tender and slow. Further out, consider rogue planets, those lonely travelers cast free from any sun. Imagine them sliding through interstellar night as silent marbles, their surfaces hidden beneath thick, insulating atmospheres. They may retain internal warmth for very long spans, like embers glowing beneath ash. The scientific anchor is clear and calm. Without a star's light, a planet can still possess heat from formation or radioactive decay, and a thick atmosphere can trap that heat. Possibly beneath such a blanket, pockets of warmth could persist for a long time, tucked away from the cold ocean of space. Picture a solitary planet as a slow lamp carried across an empty hall, modest and resolute. Now, let your attention return to how we learn of these faint, distant things. We have tools that are patient listeners rather than loud proclamations. Earlier, we touched on transits and wobble. Now we lean into the softer details, the ways light becomes a message. Picture starlight as a carrier pigeon, bearing tiny marks from everything it meets. When it passes through a planet's atmosphere, it is filtered in quiet ways. Certain wavelengths are absorbed by specific molecules, leaving dark notches in the light we capture. We call that pattern a spectrum, a rainbow of information that acts like a chemical fingerprint. Some wavelengths tell us of hydrogen and helium, the common light gases on giant worlds. Others hint at water vapor or methane or sodium. The process is subtle and slow. We wait for many crossings. We collect more light. We stack the soft signals to make a clearer picture. Interpreting spectra is like listening to a low conversation from far away and piecing together its meaning one phrase at a time. There is a tactile image for another method too. Imagine a star's light as a perfectly steady beam, and imagine a small planet passing over its face like a soft fingertip. Each such passing dims the light a little, and the pattern of dimming tells us about the planet's size and the shape of its orbit. Kepler taught us to watch those tiny dimmings patiently, counting them like quiet steps, and it found thousands of candidates simply by noticing how light blinks. This transit method gives us a map of where planets are, how often they come around, and how big they might be compared to their star. It is modest work, done with the utmost patience. Listening to the star's tiny nod, the radial velocity method, is different but similarly graceful. As a planet moves, it tugs on its star, and the star responds with an almost imperceptible pull toward and away from us. We measure that as shifts in the star's light. Imagine a pendulum so small you can barely see it swing, yet with careful watching, its rhythm reveals the weight of the planet doing the tugging. Combining the transit and the wobble gives us both size and heft, and from that we can begin to infer whether a world is rocky and compact or puffy and light.
We also learn by catching the faint thermal glow and reflected light of a planet itself. This direct imaging is the most delicate of all, because the star beside the planet is blazingly bright. To see a planet next to its star is like trying to spot a firefly against a floodlight. Scientists use special tools, coronagraphs, which block the star's central glare, and star shades, which operate like a precise shadow caster far from the telescope, to create the conditions for a planet's dim portrait to appear. The first portraits will be coarse, broad regions, bright and dark patches that hint at clouds or continents. Over time, those portraits may sharpen into time-lapse whispers of weather. Imagine watching a planetary face like a soft watercolor, gradually gaining texture as brushstrokes appear over years. We should mention our patient instruments by name, as if naming them softly comforts them into continuing their watch. Kepler began the long census of transiting worlds, teaching us the language of dimming. TESS now scans nearby skies, providing brighter, closer targets.
As a planet moves, it tugs on its star, and the star responds with an almost imperceptible pull toward and away from us. We measure that as shifts in the star's light. Imagine a pendulum so small you can barely see it swing, yet with careful watching, its rhythm reveals the weight of the planet doing the tugging. Combining the transit and the wobble gives us both size and heft, and from that we can begin to infer whether a world is rocky and compact or puffy and light. We also learn by catching the faint thermal glow and reflected light of a planet itself. This direct imaging is the most delicate of all, because the star beside the planet is blazingly bright. To see a planet next to its star is like trying to spot a firefly against a floodlight. Scientists use special tools, coronagraphs, which block the star's central glare, and star shades, which operate like a precise shadow caster far from the telescope, to create the conditions for a planet's dim portrait to appear. The first portraits will be coarse, broad regions, bright and dark patches that hint at clouds or continents. Over time, those portraits may sharpen into time-lapse whispers of weather. Imagine watching a planetary face like a soft watercolor, gradually gaining texture as brushstrokes appear over years. We should mention our patient instruments by name, as if naming them softly comforts them into continuing their watch. Kepler began the long census of transiting worlds, teaching us the language of dimming. TESS now scans nearby skies, providing brighter, closer targets for more intimate study. The James Webb Space Telescope reads faint infrared whispers, peering into atmospheres with unprecedented sensitivity, while the Nancy Grace Roman Telescope will widen our survey, catching more of those tiny flickers across broader swaths of sky. Think of these machines as bedside lamps that have been left on for a very long time, each one giving us enough light to read another page of the universe's slow story. With these gentle instruments, certain planets have come into focus as candidates for temperate conditions. They arrive as names, each a careful suggestion rather than a conclusion. Kepler 442b appears in catalogs as a small, possibly rocky world in a star's habitable band. TOI 700d is another quiet candidate that sits where temperatures could allow liquid water under the right circumstances. The point to hold close is this: candidates are invitations to study further. We do not claim them as homes, we frame them as interesting possibilities. When spectra show chemical markers that could hint at biological processes, such as certain ratios of gases, we treat them like delicate clues in a long mystery, not proofs. Always the language is tentative. May, could, possibly. Gentle verbs that keep wonder from turning into certainty. Imagine for a moment standing at the edge of a terminator band on a tidally locked planet.
Earlier we pictured the thin ring between day and night. Now hold the added sense of scale. The air there could move in slow loops, carrying heat from the blazing day side into the calm night. If the winds are moderate and the atmosphere robust enough, that strip could sustain temperate conditions for long stretches. The scientific idea is straightforward. Atmospheric circulation can redistribute heat and create stable regions. In speculation, such a ridge might host liquid water at the surface or shallow seas in sheltered basins. But again, we keep this as image and possibility, not declaration.
At the same time, we must accept that habitability is nuanced. A spectrum may show water vapor in high clouds, while the surface beneath is a furnace. Or oxygen could appear in an atmosphere through non-biological chemical cycles. The science here is careful and soft. Multiple lines of evidence must converge before an interpretation grows confident. Picture scientists piecing together a delicate puzzle, each piece a whisper of light, each piece requiring cross-checks. That humility is itself reassuring. It keeps excitement gentle and expectations measured. There is, however, an increasing intimacy to our observations. Imagine the first time humanity might see a blurred disk of a distant world, a round, dim patch neighboring its star. At first, it will be a pale suggestion, brighter at one edge, darker at another. Over months and years with repeated imaging, that blur could reveal shifting brightness where clouds drift, or where continents, if any, reflect light differently than oceans. Imagine catching the hint of a storm moving, a slow broadening of brightness that matches what we would call a weather system. It will be coarse, like seeing the perfume stain of a painting rather than the brushstrokes, but it will be indisputably intimate compared to the tiny blinks we began with. The idea that we could one day chart weather on a planet hundreds of light years away is not a promise. It is a careful projection of where patient instruments and patient observers might lead. Meanwhile, consider chemical biosignatures, the subtle imprints life could leave on an atmosphere. We search for balances of gases that, in the right context, might suggest ongoing biology. For example, a mix where oxygen and methane coexist in surprising amounts. But we always temper the possibility with alternatives. Geological processes, photochemical reactions, or peculiar climates can create the same patterns. Thus, each hint becomes a gentle question rather than a headline. Think of biosignature hunting as reading footnotes in a long, slow book. The notes are intriguing, but they need the main text to make sense. Let your thoughts drift to another image, the catalog of exoplanets as a constellation of lanterns, some bright and near, others dim and distant. Each lantern tells a different story of composition, orbit, and history. When we add more lanterns to our map, patterns begin to suggest themselves. Many small rocky worlds, many sub-Neptunes with clouds and thick atmospheres, a smattering of giants close to their stars that puff up into extended envelopes. The pattern is comforting because it indicates variety and abundance. It suggests that the cosmos does not favor only one type of world, but crafts an array of experiences. Imagine an attic of possibilities, where each dusty box holds a new, soft revelation. As our instruments improve, so does our narrative. The gentle crescendo builds as we imagine not only cataloging, but also understanding. We move from detection to characterization, from noticing a dimming to reading the composition of a sky, from the knowledge that a world exists to the sense of how it breathes and spins. The climax of this quiet arc is not drama, but revelation, the moment when a planet's portrait becomes recognizable, and we can imagine standing, at least mentally, in its breeze. Picture then a future portrait, a circled watercolor planet whose limb brightens as clouds glow in reflected starlight, whose equatorial region shows a warm patch where heat pools, whose poles shimmer with auroral curtains painted by a magnetic embrace. The scientific vision is incremental, first broad strokes, then finer details. With patient advances, we may retrieve time series data showing seasonal shifts, or detect localized storms migrating across a face. Each improvement is small, but their accumulation is steady. Imagine a slow unveiling, as gentle as drawing the curtains wider each night, until a room becomes fully visible. The instruments that will lead these refinements include upgrades and new missions that treat light with even more sensitivity. Coronagraphs tucked into large telescopes will better mask starlight. Star shades, giant, carefully shaped shadows positioned far from a telescope, offer a way to cast a darkened field in which a planet's faint glow can be seen more plainly. The James Webb Space Telescope continues to read infrared whispers, revealing molecules and temperatures. Future ground-based giants, with mirrors vast and adaptive optics that smooth atmospheric blur, will contribute their own, more focused gaze. All of these are patient hands, combining to turn a distant blur into a familiar face over many seasons of observation. As you picture this deliberate process, allow yourself to smile inwardly at the slowness. There is a virtue in time here.
The cosmos does not hurry, and our progress keeps pace in a measured, comforting way. Each new observation feels like turning another page in a large, slow book. The mood remains gentle, science as bedside storytelling, not as a flash of bright alarms.
Now let the mind wander to small peculiarities that warm the imagination. Metal snow that dusts dark landscapes with a faint shimmer, auroras that stretch into curtains of color 1,000 times the breadth of our polar displays, late sunsets under two suns where colors blend in unfamiliar but soothing harmonies. Consider the sensory detail of such scenes, how they look, how they would sound if sound could travel in thin atmospheres, the texture of sand under a stranger's foot. Remember, these are images to cradle, not blueprints to decode. They are meant to soften thought, not stir concern. There is also a gentle moral in this slow study, that uncertainty can be beautiful. We do not know everything, and that space of not knowing allows imagination to breathe. When spectra whisper contradictory hints, or when a planet straddles definitions, we do not become anxious, we become curious in a quiet way. This humility, this willingness to live with maybe, is an important companion for restful thought. It reminds us that not all questions demand immediate answers, and that some mysteries are best kept as warm curiosities. As you begin to sink further into rest, picture a final scene that blends many of our images into one softly glowing tableau. Imagine a small fleet of telescopes arrayed like lanterns on a dark shore. Each lamp lifts a different color from a distant world. Together they assemble a slow mosaic. In that mosaic, you can make out a glassy rain on a horizon, a thin twilight band hugging a terminator, a ring that trembles with slow motion, auroral ribbons painting the night. These are not bright or sudden revelations. They are whispers gathered over seasons, a communal effort of light and patience. Feel the warmth of collaboration, the human softness that tends these instruments, the steady attention that brings image into focus. And then let the picture soften, as all images should when night deepens. Let the details blur into soothing hues. Breathe with the rhythm of planetary motion, long and even. Imagine the steady orbit of a world, a slow loop that could soothe on its regularity. Let your thoughts match that pace, slow to come, slow to leave. Before the night offers full surrender, I will leave you with one small, gentle assurance. The cosmos will continue its patient turn whether we watch or not. Planets will keep their slow rhythms. Stars will go on maturing and fading. Rings will whisper as they move. The delight we take is in the watching itself, in the soft curiosity that lets us hold images like little lanterns while we sleep. If you carry any of these images with you, a sky that rains glass, a Terminator band where twilight is endless, a rogue planet moving like an ember through the dark, tuck them like pebbles into your pocket, light and comforting. If you are still awake and would like another quiet journey like this sometime, there are more voyages waiting. Otherwise, let the world of images ease away as you drift. Breathe in once, slow and gentle. Breathe out, letting your shoulders soften, your thoughts thin, your eyes fall closed. Good night.